I'm Marina. I am a research scientist at Adara and the head of Adara Research. Confidential computing is a hardware-based technology that provides encryption for data while in use. I think the first misconception around confidential computing is how it actually works. And kind of what it does. What it achieves is it gives you encryption of the data while in use. So in addition to the data being encrypted while in transit and while at rest, which are both kind of standard industry practices today, the data can also be encrypted while it's actually in process in memory. And I think another misconception is kind of what security this actually gives you. So what this does is it means that all you have to trust when you give data to this TEE, this confidential computing node, all you're trusting is that piece of hardware that the node is running on. You don't have to trust your operating system or your cloud provider or anything else in the stack. You just have to trust the stuff that's running in the node. But this doesn't always, this isn't a magic bullet though, because if there's something in the node itself that's insecure, you can still have something go wrong, right? So you just have to be careful, right? Because what you're doing is you're reducing what's called your trusted computing base to everything running inside the trusted execution environment. But you still have to make sure that the piece of hardware itself is trusted and that the code running in it is also trusted. So at Adara, we have a slightly different, what's called a threat model around our applications. So in confidential computing, again, you trust that trusted computing base, which is all the code running on top of in the TEE and the piece of hardware of the TEE. In Adara, what we do is a little bit flipped around, where you don't have to trust your workloads, and you can ensure that even if a workload is compromised, you can't get lateral movement to other workloads on the system or compromise the hypervisor, the system itself, because instead of the operating system sharing between all the different workloads, we have this hypervisor, which provides a really strong isolation boundary between the different workloads running on the system. So while both confidential computing and Adara can kind of isolate a workload, they kind of do it from different angles. So what Adara does is it isolates your system and other workloads on the system from anything that could go wrong, whereas what confidential computing does is it isolates your workload from the system. So it's kind of a slightly opposite ways of looking at it. So the type 1 microkernel hypervisor design of Adara also kind of reduces this trusted computing base in a similar way to confidential computing. And so what we can do with confidential computing core is actually achieve a lot of the similar features of confidential computing without requiring the hardware. Yeah, I think one of the biggest barriers today is trust in that hardware, because what you're doing is you're not eliminating trust, you're moving the trust from these cloud providers and operating systems to this piece of hardware. And hardware is more slow to iterate than software, right? Just because it's more expensive to build, it's harder to patch, which means that, and there have been vulnerabilities discovered in different of these trusted execution environments. And so I think one of the biggest barriers to this technology gaining broad adoption is just the maturity of the hardware itself, and it getting to the point where we're not seeing as many of these vulnerabilities that kind of negate some of the benefits of confidential computing.